Alright, I want to talk about how to graph exponential and logarithmic functions. And I want to compare it to what you should already know about how to graph quadratic functions and do transformations with those. So I first want to start with something called the parent functions. Every function belongs to a different family. And so if you think of the parent of that family being the most basic graph that belongs to that family, then these are all of the most basic graphs that go along with each separate family. So the linear family is one of the first ones you learn about in Math 1010. It's obviously just a straight line. Its basic function is f of x equals x. But there's obviously lots of different variations of that, which all are in the same family. So the quadratic graph, we know it as the parabola. The most basic parabola goes straight through the origin. It's not too skinny, not too wide, opens up. Its equation is f of x equals x squared. But we learned how to transform those. If we do something to the x squared equation, it can transform what the graph looks like. It'll still be in the same family, so it'll always be a parabola, but it could be flipped upside down, it could be made skinnier, it could be shifted left or right. Whatever we do to the x squared graph can change what this function looks like. So it's similar with exponential and logarithmic functions. We need to know what their parent looks like, because that's where we start from. So I have the two here, exponential and logarithmic. They each have different properties. And you need to memorize what the parent looks like, because the parent is where we go from. That's where we transform the function from. That's what we start with, and then we change it. So some basic properties to the exponential is that it has a horizontal asymptote at the x-axis, which is the line y equals 0. So I'll draw that in red here. That's the horizontal asymptote of exponential functions, and all exponential functions should have a horizontal asymptote. Now it may be shifted depending on what's happened to your function, because again this is just the most basic. This is some number a raised to the x power. So it could be 2 to the x, or 3 to the x, or 10 to the x. It doesn't matter what the a is, but if it's raised to an x power, that means it belongs to the exponential family, and its graph will take on this look. Another main property of the basic function a to the x is that it'll go through the point 0, 1, right through the y-axis at 1. So I call that a good starting point because we can transform from there. Moving over to the logarithmic graph, now log functions have vertical asymptotes. Their vertical asymptote is the y-axis, or that's the line x equals 0. And one of the main points that their basic function goes through is the point 1, 0, over 1 up 0. So no matter what the base of the log is, if we just have a basic log base 10 of x, it's going to look like this. It belongs to the log family, has a vertical asymptote, and it kind of starts off steep, it approaches that asymptote, gets really close to it the further down it goes, and then it continues to go up. And it kind of looks like it's leveling off, but it just grows really slowly. The exponential function is a reflection of this, actually. They are inverse functions of each other. But the exponential function gets really close to the horizontal asymptote as it approaches negative infinity. And it kind of spikes up right here. When something grows exponentially, it grows really fast over time. And so, well, it starts off slow and then grows really fast, so it goes up. So you have to know that to know how to do transformations. You have to know where you're starting from. So let me go over to here now. And I have 3 separate functions up here. I tried to make them similar so we could see what's happening depending on what family we're in. But up here I have just the function notation of what I've done to each of these families. I put a negative in front of the function, I've subtracted a number on the inside of the function, and I've added a number on the outside. So when you put a negative in front of the function, that negative reflects it over the x-axis. So that's what a negative in front of a function does. It reflects the graph over the x-axis. When you add or subtract a number on the inside of a function, that is going to transform the graph or shift it horizontally. And the thing I tell my students sometimes, it's what I learned when I was in this class, is the phrase hi-vo. So this says hi. That means horizontal inside. If you add or subtract a number on the inside of the function, it'll shift the graph horizontally. If you add or subtract a number on the outside of the function, that's going to shift it vertically. So that's my VO to stand for vertical outside. So my phrase is hi-vo. Just stands for horizontal inside, vertical outside. It'll shift my graph vertically if I add or subtract a number on the outside. So I'm just using my mouse here, so it's going to be a little bit sloppy. But look at what family we're in. We're in quadratic family for this first function. You can tell that because I have an x that's being squared, and any x that's squared is quadratic. So the negative in front is going to flip it. Let's remember what the parent function looks like, because that's where we're going to start from. The best I can, I'm going to try to draw it. It's a parabola. Remember, quadratic functions are parabolas. So this in red is where I'm starting from. Again, it's the parent. And so in blue here, I'm going to do each part. I'm going to reflect it over the x-axis. So instead of going up, now it's going down. I'm going to subtract 2 on the inside. That's horizontal inside. Now horizontal shifts go the opposite way of what you'd think. So if it's minus 2, it's going to go to the right 2. So instead of going through the point 0, 0 now, it's going to be going through the point 2, 0, but it's still going down. And again, it's really sloppy, but you get the idea. And then the plus 3, that's on the outside of the function. That's VO, vertical outside. That's going to shift everything up 3, 1, 2, 3. So let's get black here. My final graph for this quadratic, which again, this should be a review. We've done this before in both 1010 and 1050, is in black here. It's flipped downwards. The vertex is at positive 2, positive 3. Well, the same thing should apply to exponential and logarithmic, other than where you start from. It's not a parabola because it's not the quadratic family. It's the exponential family. So we have to start with the correct graph and then shift it from there. So I'll start in red again with my correct graph. Remember, the exponential family goes through the point 0, 1, and it has a horizontal asymptote at the x-axis. Whoops, and then it kind of goes up like that. So again, rough sketch, it should be going through the point 0, 1 right there, and it heads off to negative infinity right there. That's my parent function. That's where I'm going to start from. Well, I'm going to do all the same things to it. I made these functions somewhat the same. I put a negative in front, so that's going to reflect it over the x-axis. Whoops, let me get blue. So instead of going through the point 0, 1, now it's going through the point 0, negative 1. It's been reflected. I've subtracted a 2 on the inside of the function. Now inside of this function doesn't mean inside of parentheses. It's on the inside of the exponent spot because it's an exponential family. That's what the inside means. The inside of the function means you add or subtracting a number on the inside of this exponent. So that subtracting 2 is considered inside. So it's going to shift it horizontally. Remember my HI. Horizontal inside. So I'm going to shift everything to the right 2. So instead of going through 0, negative 1, now it's going through 2, negative 1. And again, I don't know, something like this. And then the plus 3, that's on the outside of the function. That's on the outside of what's being, it's not in the exponent spot. So everything's going to shift up 3. So we go up 1, 2, 3. So the final, I've used this starting point as my guide throughout here. And again, if I was doing this with pencil, I would be a little bit more neat, but this is hard with my mouse. But it's going through the point now. We were at this point 2, negative 1, and I went up 3, 1, 2, 3. So now I'm at the point positive 2, positive 2. Now everything gets shifted up 3. So even the horizontal asymptote, remember it was at the x-axis before? So it got shifted up 3 as well, so it's now at the point y equals 3. Let me get a straight line here. That's kind of thick. And can't tell if that's exactly where 3 would be. Maybe it'd be closer right there. But y equals 3 is where the new horizontal asymptote is because everything shifted up 3 units. Not just the graph, but the asymptotes as well. So the last one, the logarithmic family. This one looks a little different because the 3's in front. So I could have written it this way, and it's the same thing, negative log of x minus 2 plus 3. The 3 would be on the outside of what we're taking the log of. These two things are equivalent. But again, we need to start with our parent function. We need to start with the graph of the log, which goes through the point 0, 1. Sorry, not 0, 1, 1, 0. goes over 1, up 0. Again, a little bit sloppy, but that's the basic look of it. To get a better accurate look, you can look at this. That's the basic look of the log function, no matter what the base is. What if you don't see a base? What is that base? If you don't see a base, it's a circle there I drew, that means it's a base 10. Base 10. But it doesn't matter what the base is, any basic log function will go through the point 1, 0 and look like this. It'll have a vertical asymptote at the y-axis. So we need to do a few things. I did a negative in front. That is going to reflect it over the x-axis. When you reflect something like this, that's, whatever is below the x-axis is going to come above, and whatever is above is going to come below. So instead of an increasing graph, like the red one started out to be, now we have a decreasing graph when it got reflected. Then I have my minus 2, so that'll shift everything to the right 2. And I have my plus 3, that'll shift everything up 3. Remember that these two things are equivalent, so you would need to recognize that the 3 in front is the same as adding a 3. So after I do that, after I shift to the right 2 and up 3, I'm going to be at one of the points that my graph's going to be going through is 3, 3, I think. Let's see, because I was at 1, 0 and I went to the right 2, that made me at 3, 0, and I went up 3, that made me at 3, 3. And everything gets shifted. Even in this case, the vertical asymptote gets shifted as well. Remember, it started out just at the y-axis, so when everything got shifted to the right 2 units, my vertical asymptote did as well, so it should now be at x equals 2, somewhere right there. So anyway, I hope that helps give you an idea of transformations. If you can compare it to what you already know about quadratic, then the exponential and log family really is no different, other than you need to memorize what the parent functions look like here and here.